This is AP Calculus AB. We're in worksheet 2-2, finding U. All right, directions, we're just trying to find the outer house, the inner U, and take the derivative of the inner U. That's a typo that will be fixed in the future. And number one, the outer. So again, you're doing everything but the inside. The inside is x plus 1, so the outer is that parentheses squared. It is a powerhouse. The inner is going to be the x plus 1. And the derivative of the inner, the dinner, is going to be, well, the derivative of x is just 1. Why? Because it's technically a 1x here, and whenever you have the derivative of a linear function, you just take the coefficient. So there's our coefficient. I'm going to go ahead and erase that one for now. And then the derivative of 1 is 0. So there we go. Derivative of 1, derivative of 1 is 0, so it's like a plus 0 here. Moving on, we have the outside is going to be 3 times parentheses power of 3. The inside is going to be 4x to the negative 1. And then when I take the derivative of that, the negative 1 comes down in front. Negative 1 times 4 is a negative 4. Negative 4x to the power of. And then this is going to go down from negative 1 to negative 2. All right. And number 3, the outside is a negative 2 times that quantity to the power of 7. The inside is 1 minus 3x. The derivative, well, the derivative of 1 is 0, so I don't write that. The derivative of negative 3x is negative 3. Number 4, the outside, or the outer, is negative 1, or negative, in parentheses, to the negative 3. It's technically a negative 1, but I'm just going to leave the negative. The inside, the inner, is x squared plus 1. And then when I take the derivative of that, the derivative of x squared, the 2 comes down in front, making this a 2x to the power of, well, this 2 was a 2, I'm going to go down to 1, so I don't write the 1, I just leave it there, and the derivative of a constant is 0. And number 5, the outer is that parentheses to the power of negative 1/2. The inside, the inner, is 3x squared. When I take the derivative of the inner to get the dinner, the 2 is going to be multiplied down in front. 2 times 3 is 6, so this is going to be 6x to the power of. 2 goes down to a 1, and you don't write the 1. And number 6, the outer is a square root function, which is technically correct. You could have also said it's in parentheses to the power of 1/2. This is the same thing, right? And the inside is the x plus 1. And the derivative of that inside, you have to be careful, right? Because the derivative of x is just 1. The derivative of 1 is 0, so plus 0, but we don't write that. In number 7, the outer, I mean, technically, you're right by saying it's 5 times the cube root of whatever's on the inside. But there's another way of writing that you should get used to, which is 5 times that quantity of the inside to the power of 1/3. Again, knowing power of 1/2 is a square root, power of 1/3 is a cube root. Those are important to do. And the inner is going to be a 4x squared. To find the derivative of that inner, that dinner, 2 times 4 is going to be 8. And then x to the power of, well, 2 goes down to 1, so we don't write the 1, we just say 8x. For number 8, again, you can say the outer is a square root function, which is the same thing as that inner to the power of 1/2. And the inner is 1 minus 2x. The derivative of 1 is 0, so we don't write it. The derivative of negative 2x is negative 2. All right, and number 9, the outer is 4 times the cube root of whatever the inside is, which is the same thing as saying 4 times that inner to the power of 1/3. You should be comfortable with both of those, of course. The inner is going to be 3x, and therefore the dinner, the derivative of the inner, is just 3. Number 10, the outer is going to be negative square root of whatever the inside is, which is the same thing as saying negative that thing to the power of 1/2. The inner is going to be x minus x squared. And when I take the derivative of that, okay, the derivative of x is just 1, because it's the derivative of 1x, right? And the derivative of negative x squared, well, it's going to be negative 2, because, again, the 2 drops down in front. So there's my 2, and then I'm going to write x to the power of, this is powerhouse, 2 goes down a power down to the power of 1, and I don't write the 1, so just 1 minus 2x. In number 11, we have the outer house is 3e to the power of something. I'm going to leave it blank like that. The inner is 2x in this case. And again, it is kind of confusing, but this is going to be inner. You do have to have some sort of parentheses up here to let us know that's where it's going to go. And the derivative of 2x is just 2. In number 12, the outer is going to be negative e to whatever power that is. Again, the inside of e house is kind of like a tree house, right? Is everything up here, the top of the tree house. The inner is going to be x plus 1. The derivative of that inner, the dinner, well, there's a 1 here, so I'm going to put a 1. And the derivative of 1 is plus 0, which we don't write. In number 13, we have a log house. So for a log house, I'm going to do cursive L. Natural log of whatever the inside is, and the inside is 2x. The derivative of the inside is 2. And number 14, the outside is everything outside the parentheses, negative 4 natural log. We'll write the empty parentheses, and the inside of that is x squared minus 1. When I take the derivative, again, it's powerhouse. 2 comes down in front. This is going to be a 2x to the power of. It used to be a 2. It's going to go down to 1, but we don't write the 1. The derivative of negative 1 is 0. It's just a constant. And number 15, the outer is going to be natural log of all of that stuff all over 2. There is another way to write this that might be helpful to some people, which is you take the 1/2 out and you multiply it by natural log of whatever the inside is. These are equivalent forms. This one is slightly more helpful than that one, depending on the case. Maybe that one is slightly more helpful than that one, depending on the case. The inside, the u in this case is 1 minus 3x. And the derivative of that, well, let's check. The derivative of 1 is 0, and the derivative of negative 3x is negative 3. All right, backside. What are we doing down here? All right, so we've got some trig house now. The outer is going to be 3 sine of whatever the inside is. The inside is x squared. The derivative of that x squared is 2x, again, because the 2 comes down in front, and 2 goes down to a power of 1. For number 17, the outer is cosine of whatever that inside is. The inner is 1 plus x squared, and the derivative of that, the derivative of 1 is 0, plus the derivative of x squared, 2 comes down in front, and we've seen, again, that's just 2x. Number 18, for tangent, I have negative tangent of whatever the inside is. The inner is 5x minus 4, and the derivative of that is 5, again, because constant is 0, 5x turns into 5. Number 19, we have cosecant of 3x, and that's going to be cosecant of the inside, all over 2. Again, you could also write this as 1/2 times the cosecant of whatever the inside is. It's another form that you should get used to. The inside is 3x, and therefore the derivative of that inner, that dinner, is 3. In number 20, we have negative 2 secant of x to the power of 3. So the outside is going to be negative 2 secant of whatever the inside is. By default, if there are no parentheses for trig house, you assume whatever comes next is directly inside. You can't have any function that looks like this where 3 is outside the parentheses, because whenever you have a power, the power is usually inside. Like if I wanted to say secant, here, let me write this down. This is kind of an important explanation. I know it's just randomly in this video, but if I have secant of x and I want to take that entire thing to the power of 3, I don't just put the 3 out here. To avoid confusion, we put the 3 inside. So this is really secant cubed of x. So I can write secant cubed of x like this, which is the equivalent of the line that I've written up here. So this power of 3 is not applying to the secant, it's applied to the x. It is kind of order of operations as well. All right, so moving forward, the inner here is going to be x to the power of 3, and therefore the derivative is going to be 3x to the power of 2, because I went down from 3 to 2. All right, so now we have new directions because these have an inner that we have to identify. So we'll identify the house. So this is going to be log house, etc. The inner, the immediate inner is all that e stuff. Let's just do one, right? So the outer is going to be natural log of all of this stuff. The inner is going to be e to the power of all of that stuff. And then that all of this stuff right here, the inner is that 2x plus 1. 2x plus 1. And now I'm going to take the derivative of that inner. So if I call the derivative of the inner the dinner, the derivative of the inner is the dinner. Or some people, I don't think we should call this the dinner because I'm not taking the derivative twice. It's the derivative of the inner, so it's the dinner. So the dinner is going to be 2 because the derivative of 2x is 2, the derivative of 1 is 0. You're used to that by now. I'm going to stop explaining it. All right, number 22. The most outside house is going to be sine of all that stuff. inside is cosine of all that stuff, and inside the cosine is an x, and the derivative of x is just 1. All right, number 23, the most outer is sine of stuff. The inner is going to be cosine of stuff, and that stuff is 2x in this case. The derivative of 2x is 2. In number 24, the most outside house is e to the power of some stuff. That stuff is natural log of more stuff, and that more stuff is 1 minus 3x. 1 minus 3x. The derivative of 1 minus 3x, be careful that you get your negatives right. The derivative of 1 is 0. The derivative of negative 3x is negative 3. Number 25. So this is the case I was talking about above. So remember that this is the same thing as saying tangent of 3x, and this entire thing to the power of 2. I know it's confusing notation, but this 2 really comes out here. And it's to avoid confusion when we drop the parentheses. So the first outer house is really stuff to the power of 2. That is the most outer house. Stuff to the power of 2. I imagine that most people have to look at the answer key, or at least this video for number 25, because it's a weird one. It's weird trigonometry notation. And what is the stuff that goes in here? Well, it's tangent of 3x. So tangent of stuff. And what is that stuff? I already said it. It's 3x. 3x. And the derivative of 3x is just 3. All right. That does conclude AP Calculus's AB's worksheet 2-2 for finding u. There it is. Thanks for watching, guys.